Hi class, we're looking at question 9. A moving van is leaving the house traveling at 40 miles per hour. The family leaves a half an hour later following the same route. They travel at an average speed of 60 miles per hour. Here the problem is stepped out for you. Use the important clues from the questions of A, B, and C to help you plan out this problem. It says define a variable for the time traveled by the moving van. Well, if we let the time traveled by the moving van to be t, okay, again, it's really important that you write this down and label it. What is the t here? So then the family left 1/2 an hour later. Remember, it's important to keep our units consistent. So we're going to, instead of saying minus 30, which would be 30 minutes, we're saying minus 1/2, which is a half an hour later. That's the time the family left the house. Okay? So now we know that the rate of the moving van is 40 miles per hour. And the rate of the family is 60 miles per hour. Remember, distances are going to be the same here because we want to know when they meet up. Okay? Actually, does the question ask this? I apologize. The question does not even ask us when they meet up. So you're not solving anything here. You're just writing, completing the table, putting the information you know, which is the rate of the moving van and its time, and the rate of the car and its time. Multiplying them together will give you the distance traveled. If you wanted to find out when they would meet up, you could set these two, the distance traveled and the of the moving van and the distance traveled of the car to be equal to one another, and you could solve for t to find the time that it would take for the family to catch up to the moving van that had that 1/2 an hour head start. Hope this helps. On to question 11. Question 11 looks at Juan driving to work. Because of traffic conditions, he averages 22 miles per hour. He returns home averaging 32 miles per hour. The total time of the trip is 2¼ hours. So we need to think about the fact that Juan is driving to work and then back. Okay? So if you think about that, the distances are going to be equal. Okay? The distance to and from work are going to be equal. Now going to work, he's going slow at 22 miles per hour. And then coming home, he gets to go a little faster at 32 miles per hour. Now the time here is critical. We don't know the time that it took him to get to work or the time it took him to come home, but we know the combined time of 2½ hours. So let me ask you this. If he traveled to work and it took him 2 hours to get to work, how much time does that leave him to get back home? Only 1/4 hour. If it took him an hour to get to work, he would have 1 hour and 15 minutes to get home based on that total time of 2:14. You always want to ask yourself, well, what if? And place some numbers in there. We recognize that we take 2¼ and subtract the x from that to get the time he spends going home. Okay, so we're going to subtract 2¼ minus x. And then that would leave x for the time going to work. You could do the reverse here. The situation would be set up pretty much the same. So now we need to write and solve an equation. Again, the distances are equal, so we're going to set up 22 times x on the left side and 32 times 2, and I'm going to change that to 2.25 minus 2.25. 2.25 minus x, close parenthesis. We then need to distribute. We're left with 22x equals, we get our calculator, 32 times 2.25. So we have 32 times 2.25 leaves us with 72. So back to my problem, I have 70, pen. I have 72 minus 32x. I'm going to add 32x to both sides. And I'm left with 55x equals 72. 72 divided by 55. Again, where's my calculator? 72 divided by 55 gives me 1.30. And then we have the time coming, that would be the time driving to work, which is what we left our x to be, which would be 1.30 hours. The final question we're looking at is question 13. We have John and William leaving their home in opposite directions. They're traveling in a straight road. John travels 20 miles per hour faster than William. After 4 hours, they are 250 miles apart. So in this situation here, their distances are going to total 250. So the distance of John, who is traveling 20 miles per hour faster than William, so if we say x plus 20, this is going to be John, and William then would be just x. Solving this a little differently than the textbook did, but we should still get the same answer. Now, we know the time for both men is 4 hours. So rate times time. So 4 times x plus 20 plus 4x, which is this was John here, and this is William. Now, again, I did this a little differently than in the book. The total distance is going to equal 250. Remember, we're solving for x, and x in this case will be William's speed. See William, and here's the x for William's speed. Again, labeling things. And I'll just put Will's speed there. Okay. We now need to distribute the 4x, the 4 to the x and the 20, so we're left with 4x plus 80 plus 4x equals 250. Combine like terms, 8x plus 80 equals 250. And then subtract 80 from both sides. And I'm left with 8x equals 170. Divide both sides by 8. And I'm left with 170 divided by 8, which on my calculator, 170 divided by 8 gives me 21.25, which is 21 1/4. X equals 21.25, or 21 1/4. And then if we go back up, we find it says write an equation to find John's rate and William's rate. Well, x, we were told, we identified x as being Will's rate. So Will is going to be 21 1/4, or 21.25, and then we have to add the 20 to that to get John's rate of the 41 1/4, which you can see here in the answers. But if you notice, this is the equation they set up with the minus 80, and ours worked the same way, except we were solving for different parts of the problem. Hope this helps. Have a great evening. Remember, keep practicing these problems.